think this should about wrap it up. I want to just introduce some notation and talk about maybe tangent line. So let's just get after it. What we got? We want to just find an equation of the tangent line to y equals e to the x minus 1 over e to the x plus 1 at x equals 0. Awesome. You're like, dude, we're doing this again? More tangent line? Let's go. Right, but we don't have to do that algebraic definition of derivative anymore, which is that's what makes these problems a pain in the ass. Once we have the shortcuts, come on, life's good. So now that we're Calc 1 students and we're starting in on derivative tricks. That's essentially chapter 3. It's called derivative tricks. It's what you're going to use from here on out because you don't want to reinvent the wheel every time. We have processes we can use. Anytime, if you're ever confused on what to do, take a derivative. From here on out in this class until we get to integration, don't know what to do? Shit, can't hurt, might help. Take a derivative. So before even thinking, I just see there's a function and go, yeah, let's just take its derivative. But I don't want to write y prime. For what we're going to do, it's actually a little bit more powerful to be able to write dy dx. I want to write in the Liveness notation. And we're going to show you a little something different. It's okay, and you just have to be able to read it. You don't have to write it. You can choose to write it in other ways. But while we're learning all this, we're trying to become much more proficient in how we write and how we present material. So here we are, the trick. Low, so that's e to the x plus 1, times the derivative of high. That's just going to be e to the x, minus high, e to the x minus 1, times the derivative of low. That's just e to the x, and then square at the bottom. Cool, 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 cool. Let's clean it up and see if anything happens to this numerator, because I don't want to be plugging in x equals 0 with this much work. Just too much. Let's just see what happens. So we're going to get this first one. We got to transfer that in. So we get e to the x times e to the x. Now I'm going to write this first, just separate. Now you know e to the x times e to the x, that would be add your exponents because you have the same base, right? Because you wouldn't say x times x was just equal to x, right? You wouldn't just multiply 1 times 1 and go, yep, it's 1 times 1. Hell no. It's 1 plus 1, right? To make x squared. You have the same base. If you have the same base, you add your frickin' exponents when you multiply. So that's not e to the x squared or anything like that. That's just e to the 2x. Plus the other one, 1 times e to the x. This shit will come back, I promise you. You will need to know this trick. When we get to integration, that's how I'm going to try and trick you. That's what I'll try and do to trick you. There's a game that e to the 2x is just e to the x times e to the x. If you know that, you'll be bulletproof. All right, get back to the problem. Shut up, dude. You can do it. Okay. Now, careful. We got a little negative here. So everything we bring in, we're going to change its sign. So again, we're going to be like, all right, we got e to the x times e to the x. We just freaking talked about that. That's going to be negative e to the 2x. And now we're going to bring that e to the x times negative 1. That's negative e to the x, but there's that negative hanging out right in front, so that changes to a positive. Be very careful with sign error. It is a killer. Be very mindful. Now this is great news. We got that e to the 2x and we got that negative e to the 2x. Cancels. All that stuff starts to clean up. This looks like a much more, I don't know, simpler problem to put together now by plugging in values. So e to the x plus e to the x, that must give us 2 of those e to the x's. And now we have e to the x plus 1, all squared. There's our Liveness notation derivative. We're super happy with ourselves, but only thing that does is it gives us access to the slope of the tangent line, right? That's the derivative will tell us the slope of the tangent line at any value of x. It's in the domain of the function. Here's the new notation. So to plug in this x equals 0 into our function, or how we'd say it, right? Because we have things like f of 0, right? When we have a function, we say, hey, we're going to plug in 0. Well, how do we do it with Liveness notation? And here it is. We write our, let's get into there. We're going to write our dy dx, but then we're just going to draw a straight line down below it. And at the bottom, just write what value of x we're about to plug in. And we look back up and, oh yeah, that was that number from up above. We're saying we want to plug in 0. That's the equivalent of saying like f of 0. Okay, it's in the Liveness notation. Probably not the notation you want to use. Cool. But you got to be able to frickin' read it. All right, you might want to use a different notation, but you got to be able to read it, so that's why we're talking about it. So now we can plug it in. That's 2e to the somethings over e to the something plus 1, all squared. We look back, that something is that 0, so we're just going to plop those things in right there. And here we go, 0, 0. Anything raised to the 0th power other than 0 is going to be 1. So we get, what's that, 1 plus 1 all squared, 2 over 4 is equal to 1/2, and that's also known as the slope of the tangent line. So we saw that dy dx and that straight line down with an x equals 0, we're just saying plug in x equals 0. Once we're to this point, we just have y minus y1 is equal to the slope times x minus x1. Well, that y is going to stay there, that x is going to stay there. We just got to start plugging things in. Well, there's the slope of our tangent line. That's 1/2, so we pop that in. There's our x value. That's going to be 0, so that makes life convenient. But shoot, we need to go get our y value. And how this problem might be different than what you've seen in the past is this one doesn't give you your y value along with it. You got to take this thing and pop it in to go get your answer. Well, let's go take a look. We're like, it's going to be y is equal to e to the something minus 1 over e to the something plus 1. What are we plugging in? What are we plugging in? That's a 0. So plug in the 0. We get 1 minus 1 over 1 plus 1. That's 0 over 2, and that's freaking 0. Hey, that's good news. So what do we have? Y is equal to 1/2 x. And this. That's a terrible color. And this here would be the equation of our tangent line. Cool. Just keep noting over and over and over. Slope of the tangent line is the derivative at any freaking point, as long as it's in the domain. Here's your little new notation. We kind of introduced things to get. Maybe learning that e to the 2x is e to the x times e to the x. There's some stuff in there. That'd be the main points. Let's try one more piece of like notation. I'm gonna do one that's real freaking simple here. I'm going to do one that's real simple. Let's just go e to the x times x squared. You know what I mean? I'm just going to go real mellow. But I want to know what's this. Find me f double prime of 3. What's that mean? What's that mean? Now this is somewhere where I used to make mistakes. I want to plug the 3 in first and then you take its derivatives, but that will just give you 0 every time. Because derivative of a constant. So I always wanted to like plug the number in first. So what this is saying is take not just one derivative, but take 2 derivatives. Take 2 derivatives, and then once you're freaking done with that, then you go and you plug in your 3. So let's go solve for this. This is a little product, no biggie. You can do this. Okay. So f prime of x. Now if you want to, I like this method. Just that's f, that's g, and then just do one of these, and that's how your product's going to work every time. So let's take that first one. E to the x times x squared, e to the x times x squared, plus e to the x times 2x, or let's write it as 2x e to the x. So there's a first derivative. Now let's go find a second derivative. Well, that's actually not so bad. Well, because we already know the derivative of this. That's f of x. So we don't even have to stress about that. That's not that big of a deal. So for the first part, I'm going to skip some steps and just write down it's e to the x, x squared, plus 2x e to the x. That's just the derivative of this. But now, we need to take a derivative on this. So let's play that game one more time. Let's just do this. 2x e to the x. Drop a 2. Write e to the x, right? The derivatives. That's an f and that's a g. Now go like this. So write in 2x e to the x plus 2 times e to the x. Now once we clean it all up, it looks like we got some doubles. E to the x, x squared. We got 2x e to the x plus 2x e to the x. That's plus 4x e to the x plus 2 e to the x. All right, we found a second derivative. having to be very careful and mindful of what we're doing. Now we can take our value of 3 and plug it in. We can say, all right, f double prime of 3 will be equal to e cubed, 3 squared, plus 4 times 3, times e cubed, plus 2e cubed. So what's this? 9e cubes plus 12e cubes plus 2e cubes is going to give us, what's that, 21, 23 of them? 23 of them? 23e cubes. So, hope it helps. See you in the next section.